Sticky atoms show how atoms join together to make molecules. But you don't need sticky atoms to follow this. Opening the kit, you'll find 6 different kinds of atoms, each colour-coded on the inside lid, so we can tell them apart. The little white ones represent hydrogen atoms. But first, let's do a thought experiment. Imagine a box filled with hydrogen atoms. Atoms are always moving, and they crash into each other. When 2 hydrogen atoms collide, they stick together to make a pair of hydrogen atoms, called a molecule. If a third hydrogen atom hits, it just bounces off. This means that hydrogen atoms can only bond once, and that's it. We can write this molecule showing its symbols inside the atom circles, with a stick joining them. This is called the ball and stick diagram. And the join between the atoms is called a chemical bond. A shorter way is to drop the atom circles and just show the symbols and stick. This is called the structural formula. An even quicker way of writing it is H2, with the little 2 written below as a subscript, counting the number of hydrogen atoms in the molecule. This is called the molecular formula. Pretty soon, all the hydrogen atoms will pair off and form H2 molecules. Let's now do it with sticky atoms. Take 2 white hydrogen atoms out of the kit and hold one in each hand. Now bring them together until they stick. You might have to twist the atoms so that the magnets line up. Now you've got a pair of hydrogen atoms stuck together, which is an H2 molecule. Easy peasy. The magnets holding them together represent their chemical bond. Actually, real chemical bonds use electrical forces, but magnetic forces mimic them well. H2 molecules are too small to see with our eyes, but trillions of them make a gas that can inflate a balloon which we can see. And it floats. Surprisingly, hydrogen gas is explosive. Fantastic molecule number 2 is H2O. Let's do our thought experiment by putting an oxygen atom into a box full of hydrogen atoms, like before. When a hydrogen atom hits an oxygen atom, it sticks. When another hydrogen atom hits, it also sticks. But a third hydrogen just bounces off. This means that oxygen can bond twice, and then it's done. This guy is officially known as the Mickey Mouse molecule. Just kidding. Let's make Mickey Mouse with sticky atoms. Take a red atom out of the kit and check what kind it is. It's an oxygen. How many little magnets does it have? 2. Take a hydrogen atom out of the kit and stick it onto the oxygen atom. You don't have to twist the magnets this time because the filament tips can freely rotate and will line up by themselves, thanks to sticky atoms' ingenious design. But oxygen's still got a bond that isn't being used. This is an unsatisfactory situation for a molecule, and it will look for another atom to bond with to complete its bonding power. Take a second hydrogen atom and put it onto the oxygen atom. Now the molecule is stable. Here's its ball and stick diagram, although scientists don't usually use these because they're designed as notation for beginners. So let's forget about them from now on. And here's its structural formula. And the molecular formula is simpler, with just symbols and numbers. H2O1. This tells us that there are 2 hydrogen atoms and 1 oxygen atom in the molecule. But when there's only 1 atom of a kind, scientists drop the number 1 to make it even shorter. So the formula becomes H2O. It's even wrong to write the number 1 here. Do you know what the formula for this is? The substance that many H2O molecules make is water. A single drop of water is made of 3 billion trillion H2O molecules. Fantastic molecule number 3 is ammonia, NH3. Take out a blue atom from the kit and check the colour code. It's nitrogen. How many hydrogen atoms can you put on it? 3. Scientists call this bonding power the atom's valency. Nitrogen's valency is 3. Oxygen's valency is 2. And hydrogen's valency is 1. Here's its structural formula. And the molecular formula is NH3. This tells us that there is 1 nitrogen atom and 3 hydrogen atoms in the molecule. We could have written it the other way around as H3N, as this tells us the same thing, 3 hydrogens and 1 nitrogen. But scientists normally write it NH3, and we'll explain that later. For now, both ways are correct. But could we write it N3H? This tells us that the molecule has 3 nitrogen atoms and 1 hydrogen atom, so it's wrong. Let's go back to NH3. The substance that NH3 molecules make is ammonia, a stinky gas that dissolves well in water. It's often used in cleaning agents, giving them a strange smell. Fantastic molecule number 4 is CH4. Aussies pronounce it methane, and Americans pronounce it methane. So it's methane from now on because I'm an Aussie. Take out a black atom from the kit and check the colour code. It's carbon. What's carbon's valency? That's the same question as how many hydrogen atoms can you put on it? Which is 4. Here's its structural formula. And the molecular formula is CH4. Scientists usually write carbon first in formulas. This tells us that there is 1 carbon and 4 hydrogen atoms in the molecule. The substance methane is a colourless, flammable gas that's used in cooking. And famously comes out of both ends of cows. Like hydrogen, methane molecules float upwards in air. Fun fact, pure methane doesn't smell. Some other molecules are responsible for that. Here comes one of them. Can you write its molecular formula? 2 carbons, 6 hydrogens and a sulfur atom. C2H6S. One of our Fantastic Four molecules is an element. Which one? Both of the H2 atoms are hydrogen, so it's made of only one kind of atom, making it an element. How about H2O, NH3 and CH4? Each of them is made of two kinds of atoms, so they can't be elements. Instead, scientists call them compounds. You can easily tell an element from a compound by looking at its formula. If it's got one symbol, it's an element. If it's got two or more symbols, it's a compound. You ignore the numbers when doing this. The Fantastic Four are simple molecules, but they're incredibly important. For example, over half of U is H2O. And the cool thing is that they show how atoms can make 1, 2, 3, and 4 bonds. The next lesson shows how atoms can bond twice to each other. How can they do that?